Hello. In the previous videos that I have created on flow through pipes, I have covered almost all the topics of this chapter, and in today's video we'll be solving the gate questions which have been asked in the previous year examinations. The first question is, due to aging of a pipeline, carrying capacity has decreased by 19%. The corresponding increase in the Darcy-Weisbach friction factor is dash percent. First of all, we know that Darcy-Weisbach equation is 4FLV square by 2GD. HF is equal to. Here, as we are having the friction factor, I'll just write this as F dash because F dash is equal to 4F. So this will be F dash LV square upon 2GD. Now we'll be replacing velocity, and we already know that discharge is equal to area into velocity. Therefore, velocity will be equal to discharge upon area. It will be Q by A whole square. Now this will become F dash L Q square upon area is pi by 4 d square, which will be pi by 4 d square whole square. So it will be pi by 4 square into d square whole square, which is d raised to 4 into 2gd. You can use either small d or capital D to denote your diameter. Now this will be F dash L Q square upon pi square d raised to 4 into d will be d raised to 5 into 2g divided by 16 will come and it will go up. So it will become 16 into F dash L Q square upon pi square d raised to 5 2g. Now this pi square into 2 into 9.81, and I'm dividing 16, that is equal to 12. You can calculate it. So this will be F dash L Q square upon 12 d raised to 5. Now this F dash is equal to 12 d raised to 5 HF upon LQ square. We wrote the equation making F dash as head of the equation. क्वेश्चन में हमें दिया गया है कि कैरिंग कैपेसिटी डिक्रीज़ हो रही है बाय 19% and we need to find the increase in F dash. So we have got a relation from this equation which is F dash is inversely proportional to Q square. और इससे ही हम लोग ढूंढेंगे कि फ्रिक्शन फैक्टर में कितना इंक्रीज़ होगा. As it is given to us that carrying capacity is decreased by 19%, it means that initial carrying capacity was Q, which has reduced by 19%, which is 19 divided by 100 into Q. So it will be Q minus 0.19 Q, which is 0.81 Q. And this I'm writing here, F dash is equal to K upon 0.81 Q whole square. K is just a constant. And this comes out to be 1.52 K upon Q square. Now as this is 1.52, इसका मतलब क्या होता है कि इंक्रीज़ कितने से हुआ. K अपॉन क्यू स्क्वायर हमारा क्या है, F डैश है. तो इंक्रीज़ कितना हुआ, 1 + 0.52. इतना इंक्रीज़ हुआ, इसका मतलब 0.52 जितना इंक्रीज़ हो रहा है. तो 0.52 इंटू 100 करते हैं तो विल गेट द परसेंटेज एंड दैट विल बी 52%. The next question is, while deriving an expression for loss of head due to sudden expansion in a pipe, in addition to continuity and impulse momentum equation, one of the following assumption is made. इसके लिए हमें वो केस याद करना पड़ेगा सडन एक्सपांशन वाला. If you have not seen that video, then I'll suggest you to watch that. Here, let me just remind you. जब हम लोग वो केस पढ़ रहे थे तो जब सडन एक्सपांशन होता है तब एडीज फॉर्मेशन हो रही थी. I'll just draw this again, the case of sudden expansion. Now here in this portion and in this portion, eddies formation took place, and for this we had given it a pressure which we had denoted it with P dash. And then while we were deriving the equation, I had told you that experimentally it was proved that the pressure in this portion where the eddies formation has taken place, which is P dash, is equal to the pressure at the first section, which is P dash is equal to P1. Now from this discussion, it's clear that our correct answer is the mean pressure in the eddying fluid is equal to the upstream pressure. Now let's see the next question. In the Bernoulli's equation used in pipe flow, each term represents dash. So each term in the Bernoulli's equation represents energy per unit weight. The question is, three pipes of lengths 800 meter, 500 meter, 400 meter and of diameter 500 mm, 400 mm and 300 mm respectively are connected in series. Lengths are given to us. I am denoting it with L1, L2, L3, and also the diameter is given to us for the three pipes, which will denote it as D1, D2, D3, which is D1 is equal to 500 mm, D2 is equal to 400 mm, and D3 is 300 mm. It's given that the pipes are connected in series, so we'll have to use that formula. These pipes are to be replaced by a single pipe of length 1700 meter. The length of the equivalent pipe is given to us, which is 1700 meter. Find the diameter of the single pipe. We need to find the diameter. We already know the equation for length of equivalent pipe when the pipes are connected in series, which we call it as the Dupuit's equation, which is L upon D raised to 5 is equal to L1 upon D1 raised to 5 plus L2 upon D2 raised to 5 plus L3 upon D3 raised to 5. Here we'll just place all of these values, but D is in mm, so we'll have to write it in meter. L is 1700, which is given in the question. L1 is 800, D1 is 500 mm. Writing it in meter, it will be 0.5, which is 500 upon 1000. So this will be 0.5 raised to 5 plus L2 is 500 and D2 is 400 mm. So it will be 0.4 meter plus L3 is 400 and D3 is 300 mm. So D3 will be 0.3 meter, which is 400 upon 0.3 raised to 5. We just need to solve this, and after solving it, we'll get D raised to 5. On solving the right hand side, I'm getting 239037. Left hand side, I'm having 1700 upon D raised to 5, which is equal to 239037. So D raised to 5 will get multiplied with 239037 into D raised to 5 is equal to 1700. From that, I'll get D raised to 5 is equal to 1700 divided by 239037, and division of this comes out to be 0.00718 raised to 0.2, which is raised to 1 by 5. 1 by 5 is 0.2, and finding this root, we get D is equal to 0.3718 meter. We have the options in mm, so it would be 371.8 mm, which is 0.3718 into 1000. This is the correct answer. The next question, a pipeline diameter is given to us as 0.3 meter and length is 3 kilometer, carries water from point P to point R. The piezometric heads at P and R are maintained at 100 meter and 75 meter respectively. To increase the discharge, a second pipe is added in parallel to the existing pipe from Q to R. The length of the additional pipe is also 2 km. Assume the friction factor F is equal to 0.04. Here, as you can see, this is the single pipe, and this pipe they have added in order to increase the discharge, which they have added in parallel. What is the increase in discharge if the additional pipe has same diameter, which is 0.3 meter? So here, as per the first question, we need to find the increase in discharge. और ये जो एडिशनल पाइप जो इन लोगों ने रखी है पैरेलल में कनेक्ट करके, उसका डायमीटर सेम है विच इज़ 0.3 मीटर. तब डिस्चार्ज में कितना इंक्रीज़ होगा ये हमें ढूंढना है. फर्स्ट ऑफ ऑल we'll find the difference between the piezometric heads. The piezometric heads are already given to us, which is 100 meter and 75 meter. P and R के लिए क्वेश्चन में दिया हुआ है, वो हम यूज़ करेंगे. So the difference between the piezometric head will be 100 minus 75, which is equal to 25 meter. This we have got the difference between the piezometric head, which will be our HF. The next thing is given to us. We need to ignore the minor losses. We'll just consider the major loss, which is the frictional loss. First of all, let's find the initial discharge, which is Q1. जब हमारे पास सिंगल पाइप है तब जो डिस्चार्ज होगा उसे हम Q1 से डिनोट कर रहे हैं. एंड वी हैव गॉट दिस इक्वेशन HL is equal to FL_Q² upon 12 d raised to 5. In the first question only I taught you how we can derive this. Friction factor given to us is 0.04. This head loss due to friction I told you, which is 25, is equal to 0.04 into the length given to us is 3 kilometer. 3 kilometer is equal to 3000 meter, which is into 3000 into Q square, which is Q1 square, upon 12 d raised to 5. The diameter given to us is 0.3 meter, so it will be 0.3 raised to 5. On solving this, we'll get Q1, which is equal to 0.0779 मीटर क्यूब पर सेकेंड. तो ये हो गया डिस्चार्ज जब हमारे पास सिंगल पाइप थी. अब हमने एक पाइप ऐड की है in parallel in order to increase the discharge, and for that again we'll find the discharge. Here this is given to us as 1 kilometer and 2 kilometer, and this is 2 kilometer. The lengths are given to us in the question itself. We'll be using this, and from this we'll find our Q2. Here suppose say this entering discharge is Q2, then it will get divided like this, here and here in both of these pipes, saying that half the discharge goes in the first one and half in the second one, which is Q2 by 2 and Q2 by 2. Now we'll use the equation for head loss due to friction. It will be HL is equal to HPQ plus HQR, because in both of the pipes we'll be having head loss due to friction. Here I'll just write that 25 is equal to FLPQ Q2 square upon 12 d raised to 5. The diameter is same, which is 0.3 meter, plus FLQR into Q2 by 2 whole square upon 12 d raised to 5. Now we have 25 is equal to The friction factor given to us is 0.04 into LPQ, which is length of PQ is 1 kilometer, so it will be 1000 meter into Q2 square upon 12 into d raised to 5, d is 0.3 plus 0.04 into LQR is 2 kilometer, so it will be 2000 into Q2 by 2 whole square, which is Q2 square upon 2 square is 4 divided by 12 into, again d raised to 5, d is 0.3 raised to 5. Now we need to solve this in order to find Q2. 25 is equal to 2057.61 into Q2 square. Therefore we get Q2 is equal to 25 upon 2057.61, and the square root of that will come. So we'll get Q2 is equal to 0.1102 meter cube per second. Now we'll find the percentage increase in discharge, which will be equal to Q2 minus Q1 upon Q1 into 100. This is how we'll find the percentage increase in discharge. Q2 is 0.1102 and Q1 is 0.0779 divided by 0.0779 into 100. On solving this, we get the percentage increase in discharge, which is equal to 41.4%. Here in this question, we are having two sub-questions. So the second question is, if there is no restriction on the diameter of the additional pipe, what would be the maximum increase in discharge theoretically possible from this arrangement? In the first question, it was clearly stated that we have to use the same diameter, which is 0.3 meter, and here it is given that there is no restriction on the diameter. So for this case, what will be the increase in the discharge? Now first of all, diameter is very much large, as it is given to us that there is no restriction on the diameter. And if the diameter is very much large, तो क्या होगा कि जो head loss है वो 0 हो जाएगा. Why? Because we know that HF is equal to 4FLB square upon 2GD. Now if our D is becoming equal to infinite, then obviously 1 upon infinity will be 0. That's why our head loss will become 0. इसका मतलब क्या होता है कि QR जो पाइप है वहाँ पे कोई भी head loss नहीं होगा. That is why we'll be considering the head loss only for the pipe PQ. So I'm just writing it here that head loss will occur between P and Q. And we'll use this equation, which is HL is equal to FLPQ Q3 square upon 12 d raised to 5. Here I am denoting the discharge by Q3 because this is a new case. Therefore we'll get 25 is equal to, friction factor is 0.04. The length of PQ is 1 kilometer, which is 1000 meter, into Q3 square upon 12 into d raised to 5. For PQ, the diameter is 0.3 meter, so it will be 0.3 raised to 5. Therefore, we'll get on solving this, Q3 is equal to 0.135 meter cube per second. Now in the question, it is asked to us that we need to find the maximum increase in the discharge. For that, we'll use this formula. Percentage maximum increase in discharge will be equal to Q3 minus Q1 upon Q1 into 100%. Why? Because we need to find the maximum increase in discharge. सो इस केस में हमें जो डिस्चार्ज मिला है हम वो यूज़ करेंगे, और दूसरा जो हमें सब सिंगल पाइप थी तब जितना डिस्चार्ज था वो यूज़ करेंगे. So we get Q3 minus Q1 upon Q1 into 100, which is 0.135 minus Q1 was 0.0779 upon 0.0779 into 100. On solving this, we'll get the percentage maximum increase in discharge, which comes as 73.29%. The next question is, a fire protection system is supplied from a water tower with a bent pipe as shown in the figure. The friction factor F is 0.04. Ignoring all the minor losses, the maximum discharge Q in the pipe is dash. We have already seen the equation for HF in terms of discharge. We'll just use that here. HL is equal to F dash L Q square upon 12 d raised to 5. Now here we'll have to take the length of the bent pipe, which will be 150 plus 25, which is 175 meter. The diameter given to us is 100 mm. From the diagram we are also having the head loss due to friction, which is 25 meter, and this 150 plus 25, which is the total length of the bent pipe, so it will be 175 meter. That is 25 is equal to 0.04 into 175 into Q square divided by 12 into D which is 100 mm, 100 upon 1000, which is 0.1 raised to 5. On solving this, we'll get discharge in meter cube per second, which is Q is equal to 0.0207 meter cube per second. We have the options in liter per second, so multiplying this by 1000, we get it as 20.7 liters per second. Let's see the next question. A single pipe of length 1500 meter and diameter 60 centimeter connects two reservoirs having a difference of 20 meter in their water levels. The pipe is to be replaced by two pipes of the same length and equal diameter to convey 25% more discharge under the same head loss. If the friction factor is assumed to be same for all the pipes, the value of D is approximately equal to which of the following options. यहाँ पे हमें बोला गया है कि सिंगल पाइप को हमें रिप्लेस करना है दो पाइप्स से. So here suppose I'm taking the two pipes like this in parallel. Then after again it will become a single pipe. Initially वो एक single pipe थी, उसे हमने replace किया. We made it as two pipes which are connected in parallel, and then again it is becoming a single pipe. यहाँ पे हम लोग पहले single pipe के लिए discharge find कर लेंगे, and then we'll go for the second case, which is when the pipes are connected in parallel. So for single pipe, we'll find the discharge. HF is equal to the same formula again. HF is equal to F dash L Q square upon 12 d raised to 5. Here it is written that friction factor is assumed to be same for all the pipes, but the value is not given to us. Now this is 20 meter, which means HF will be equal to 20 meter. जो level difference दिया है हमें वो 20 meter है. Therefore 20 will be equal to F dash into L. Now L is 1500 meter into Q square upon 12 d raised to 5. D is 60 centimeter. Centimeter, converting it to meter, so it will be 60 upon 100, which is 0.6. Therefore it will be 0.6 raised to 5. Now on solving this, we'll get Q is equal to 0.112 upon under root of F dash. Because we don't have the value of friction factor, so we'll keep it like this only. Now suppose say we have discharge going into the two pipes like this, Q2 and Q2, and the coming discharge is 2Q2, which is Q2 plus Q2 is equal to 2Q2. And in the question it is given to us that two pipes have to convey 25% more discharge. From this we can write that 2Q2 is equal to 25, which is 1.25. Why? Because 1 plus 25 by 100 into Q1, so it will be 1.25 Q1, which is 25% discharge has increased. This way we'll be comparing. Now HF is equal to F dash L Q2 whole square divided by 12 d raised to 5. Here we are having 2Q2 is equal to 1.25 Q1. Therefore Q2 will be equal to 1.25 divided by 2, which is 0.625 Q1. HF is 20. 20 is equal to F dash into L is 1500 into, in place of Q2 we'll write 0.625 Q1 whole square divided by 12 into d raised to 5. F dash into Q1 square divided by d raised to 5 is equal to 0.4096. Now making Q1 square as the head of the equation, therefore we get Q1 square is equal to 0.4096 into d raised to 5 divided by F dash, and Q1 will be equal to square root of this value. Square root of 0.4096 will be 0.64, and square root of d raised to 5 will be d raised to 5 by 2 and whole divided by square root of F dash. Now we'll be comparing this Q1 value that we have got and this one. 0.112 divided by root F dash is equal to 0.64 d raised to 5 by 2 upon root F dash. Root F dash will get cancelled, and on solving this we'll get the value for d, which comes out to be 0.498 meter. Writing it in centimeter, it will be 0.498 into 100, which is 49.8 centimeter, which is approximately equal to 50 centimeter. Let's see the next question. The circular water pipes shown in the sketch are flowing full. The velocity of the flow in meter per second in the branch pipe R is dash. Here in this diagram, the velocity is given to us for P and Q, and in the branch pipe R we need to find the velocity. Here let's say that the discharge is Q1, then here it is Q2, and for this it is Q3. From this we can say that Q1 is equal to Q2 plus Q3, and then after we'll be using the continuity equation, which is A1 V1 is equal to A2 V2 plus A3 V3. We already have the diameter and the velocity is given to us. Area is pi by 4 d square. Diameter is 4 meter as it is given in the diagram. So it will be pi by 4 into 4 square into V1, which is 6 meter per second, is equal to pi by 4 into 4 square into V2, which is 5 meter per second, plus A3 V3. The diameter for the pipe R is 2 meter. So it will be pi by 4 into 2 square into V3. Pi by 4 will get cancelled, and we'll be left with 16 into 6 is equal to, again we have 4 square which is 16, so 16 into 5 plus 4 into V3, and on solving this we get V3 is equal to 4 meter per second. Hence the velocity in the branch pipe R is 4 meter per second. Let's see the next question. A 2 kilometer pipe of 0.2 meter diameter connects two reservoirs. The difference between the water levels in the reservoir is 8 meter. The Darcy-Weisbach factor of the pipe is 0.04. Accounting for the frictional entry and the exit losses, the velocity in the pipe in meter per second is dash. यहाँ पे हमारे पास दो रिजर्वायर्स है जिनको हमने पाइप से कनेक्ट किया हुआ है. डिफरेंस बिटवीन वाटर लेवल इन द रिजर्वायर इज़ गिवन टू अस विच इज़ 8 मीटर, मतलब HF हमारा हो जाएगा 8 मीटर. डार्सी-वेस्बेक फ्रिक्शन फैक्टर भी दिया हुआ है विच इज़ 0.04. और एक और चीज़ बताई गई है कि हमें फ्रिक्शनल एंट्री और एग्जिट लॉसेस को कंसिडर करना है. तो अभी फ्रिक्शनल एंट्री लॉस और एग्जिट लॉस के लिए हम फॉर्मूला देख लेते हैं. Exit loss is given by the equation v square by 2g. I'm writing it as h exit is equal to v square by 2g, and entry loss is given by the formula h entry is equal to 0.5 v square by 2g. We have considered the entry and the exit loss, and we'll be considering the friction loss. HF is equal to F dash L V square upon 2GD. F dash हमने इसलिए लिया बिकॉज क्वेश्चन में हमें फ्रिक्शन फैक्टर दिया हुआ है. Therefore friction factor F dash is equal to 4F. So we took it as F dash. Now HF, as I told you, it will be 8. F dash L V square upon 2GD. F dash is 0.04 plus, here we'll consider the exit loss and the entry loss, which will be 0.5 v square by 2g plus v square by 2g. Now let's just place all of the values. 8 is equal to 0.04 into L. L is 2000, which is 2 kilometer pipe is given to us, so it will be 2000 meter into v square upon 2g into d. D is 0.2 meter plus 0.5 into v square upon 2g plus v square by 2g. G is 9.81 meter per second square, and on solving this we'll get 8 is equal to 20.3873 v square plus 0.07645 v square, and when we solve this we'll get v equal to 0.625 meter per second, which is approximately equal to 0.63 meter per second. That is, option A is the correct answer. Let's see another question. A pipe of 0.7 meter diameter has a length of 6 km and connects two reservoirs A and B. The water level in the reservoir A is at an elevation 30 meter above the water level in the reservoir B. Halfway along the pipeline, there is a branch through which water can be supplied to a third reservoir C. The friction factor of the pipe is 0.024. The quantity of water discharged into reservoir C is 0.15 meter cube per second. Considering the acceleration due to gravity 9.81 meter per second square, neglecting minor losses, the discharge into the reservoir B will be dash. Here we are having three reservoirs A, B and C. Let me just show you by the diagram. Connected like this. This is my reservoir A, this is reservoir B, और halfway along the pipeline जो हमें दिया है वो reservoir C है. Now from the water level of A to the water level of B, that is the difference between the water level, of A and B is 30 meter. And another thing given in question is the quantity of water which is discharged into the reservoir C is 0.15 meter per second. यहाँ पे हम लोग ले लेते हैं कि डिस्चार्ज हमारा Q है और जो हाफ वे अलोंग द पाइपलाइन जो हमारी ब्रांच पाइप जा रही है वहाँ पे डिस्चार्ज जा रहा है 0.15 मीटर क्यूब पर सेकेंड. तो यहाँ पे जो डिस्चार्ज बचेगा वो होगा Q माइनस 0.15. HF इज इक्वल टू F dash L Q square upon 12 D raised to 5. Here also we are having the friction factor. From A to B we'll be having two frictional losses. Therefore we'll write that HF is equal to HF1 plus HF2. And what is HF? It is the difference in the water level between A and B, which is 30 meter. Therefore we'll write 30 is equal to HF1 plus HF2. 30 equal to F dash is given to us, which is 0.024. Then this length is 3000 meter and this length will be 3000 meter because the total length given to us is 6 kilometer and we have a pipe halfway. Therefore it will be 3000 meter and 3000 meter. So this will be 0.024 into 3000 into Q square upon 12 into D raised to 5. D is 0.7 raised to 5 plus 0.024 into 3000 into Q square, which is this time it will be Q minus 0.15 whole square divided by 12 into 0.7 raised to 5. On solving this, we get 30 is equal to 35.4 Q square plus 35.4 into Q minus 0.15 whole square. Then we'll open this bracket, which is Q minus 0.15 whole square. And again on solving this, we'll get Q is equal to 0.722 meter cube per second. In the question, it is asked us to find the discharge in the reservoir B. So it will be QB is equal to Q minus 0.15, 0.722 minus 0.15 will be 0.572 meter cube per second. In this video, I have tried to cover the maximum questions possible. If you are having any doubt in any other question, then you can mail me. You'll find my mail ID in the description. You can even ask your doubt in the comment section, or you can use the contact us form given on my website www.itiscivilengineering.com. Thank you.